Hello, folks. I think
Hey,
we have, hi, Paul. I think we have enough attendance to start. And for today, there is only one item on the agenda, which is the GKE policy management overview. John, Ray, are you on the call?
hi. Yes, I'm here. Can you guys hear me?
Yes, I can. We
Okay.
can.
Should I just get started then?
Sure.
Okay, great. Hi, guys. Nice to meet all of you. I'm John Murray. I'm a product manager working on Kubernetes here at Google. And in particular, I've been working on something we call Google Kubernetes Engine Policy Management alongside my colleague, Ray Colling, who's here, who's the engineering lead on the project. And what it is something that we've designed to kind of deal with some of the issues that our customers have run into in dealing with the federation of policies, particularly around access control and quota management and within Kubernetes, within kind of multiple cluster scenarios where you have lots of different development teams who need to share those clusters and share the resources. So I'm going to share something here. Just give me 1 second. So I'm going to share some slides with you guys. I'll just kind of walk through some basics of the product that we've been building and talk about the architecture a little bit. And then we can give a demo. So. Okay, can you guys see that? I'm assuming yes. If you can't see it, let me know.
Yes, I can see it.
Okay, cool. So let's present this. Okay. So I'll just go through some background really quickly to give you some context. This is kind of the problem that we see with a number of people who are using Kubernetes today, where they've got multiple clusters. So these gray boxes on the right would be the clusters. And then they have multiple teams who need to share those clusters. And so the typical way of separating tenants in Kubernetes, as I'm sure you're aware, is to use namespaces. And what that results in then is this kind of team times cluster setup of namespaces, where every team has a namespace on every cluster. Gradually that becomes a fairly large amount of namespaces to manage. And if you have to manage it as an administrator across clusters, changes to those policies require kind of looping through, touching all of the clusters and updating what are more or less the same policy definitions on every cluster. And so we wanted to make this kind of scenario a little bit easier to manage for people on Kubernetes, and that was the genesis of the project. So what it is a way to centrally define policies in Kubernetes in a single central source of truth. The one that we're going to talk about here today is a Git repository, but we've designed it in such a way that whatever system that can store the definitions of those policies, we should be able to support it as a central source of truth as long as the clusters can reach it and interface with it. It applies across multiple clusters, and so there's kind of a hub and spoke model where you've got the central policy store, and then all the clusters talk to that. We use namespaces for tenants, and right now it's used to manage role-based access control, so role bindings and roles, cluster role bindings, cluster roles, namespaces, and resource quota. But we're in the process of kind of broadening it out so that it will essentially handle any Kubernetes resource that people want to federate out to multiple clusters. So right now we support 2 sources of truth, Git or GCP. So for customers who are Google cloud customers, we support kind of syncing their policies over from cloud. But if you're just a Kubernetes customer that doesn't have any relationship with Google Cloud, the Git version works without any kind of interface with Google. One of the advantages we have by using Git is that we can look at these policies as code. And this is something where we're using the Git workflow to manage kind of the workflow around policy updates for administrators. And so in the same way you would kind of manage a change to code, you branch the policy, you can run pre-commit validation on it. So we've included in policy management a validator that looks at these policies and looks at them, not only syntactically, but ensures that they make sense in relation to one another. This flow supports code reviews, so multiple administrators can look at the same change and sign off on it. And then it gets merged back into the code base, at which point it's automatically deployed out to all of the clusters. And so we've taken some of the workflow that's inherent in kind of source control and tried to apply it to some of the configurations, in particular the policy configurations for Kubernetes. So what that looks like in Git is a hierarchy that's based on the folder structure. And so that hierarchy allows you to attach policies at higher levels and have them inherit down to the leaf nodes, which are namespaces. So you can see kind of an example directory structure on the right. The places where you have a namespace YAML, those are namespaces. They're kind of the leaf nodes of the tree. And if I apply a YAML at any intermediate level, it'll inherit down the tree to all of the namespaces below. All these YAML definitions are the same ones that you would say, kubectl apply to your clusters. So they're written in the same syntax and they more or less look the same way. And then this includes, as I said, pre-commit validation. So as you're going through this and making changes to it, if there's an error or a problem, we'll let you know about that ahead of time. So what I'd like to do is kind of go into a little bit of a demo here, kind of show you guys what it looks like, and we can step through some example use cases with some clusters I've got running, and look at some of the ways that we manage policy. This demo uses a repository that I've got running actually on GitHub up in the cloud. It'll show us kind of managing quota cross namespaces. So as part of our installation of policy management, we also include a admission controller that deals with cross namespace resource quota. So you can set a set of resource quota policies that apply to a pool of namespaces, so to speak, versus kind of the inbuilt resource quota admission controller, which manages things at an individual namespace level. So we'll show that, and then we'll set up some new namespaces and kind of walk through typical kind of administrative use cases. Give me a second here. I will cut over to my demo screen. Okay. Just get into my box here. Looks like my connection died while I was talking. Bear with me one second. Okay. So I've got a TMUX session set up here. I'm running 2 clusters on GCP. They're pretty much kind of basic clusters. They've got this GKE policy management system installed on them already, but there's nothing else running on the clusters other than the basic stuff. and they are synced to the repository, which you can see on the right there. So I've got a local version of that repository here on my machine, and that's just a tree view of that local set of files. And that's representative of what's synced down to the clusters right now. So there's only a couple of basic roles and role bindings that apply kind of across the cluster. I don't have any namespaces set up. I don't have any kind of tenants on my cluster yet. So what we can do is kind of get that working. So I'm going to switch to switch my kubectl context to the cluster I have in the bottom left there. And then I'm going to copy over some policy definitions that I've got sitting in another directory just to get us started. So what that's going to do is create a bunch of namespaces for the online part of my Foo Corp example here. And so online has a shipping app backend, and that shipping app has a couple different namespaces: shipping dev, which you can see kind of over here on the right, shipping prod, and shipping staging. Each of those has a namespace definition, which just sets that up. And then you can see there's also some policy definitions in here. Shipping dev has a job creator role and role binding. And then we've got a quota policy that applies across these three namespaces, and some other good stuff in there. So I'm going to commit this and push it up to the GitHub repository. And when that happens, you should see these namespaces getting created on the individual clusters. And there we go. So what's happening here is, I'm making the changes to the repository in the cloud. We're constantly polling those from each cluster, and then as soon as it's updated, that policy definition gets pulled down and applied locally. So I'll create a pod creator role binding for shipping app backend, and we can see how to set up access for some of our users. So this is for Alice at Foo Corp, and she's got this for across all of shipping app backend, and so this role binding should apply to all three of those namespaces. And the way we accomplish that, because role bindings are namespace level resources in Kubernetes, is we flatten this out when we pull down that policy to the cluster, and it actually results in three separate role bindings. So if I wanted to test that by looking at the shipping dev, I can see that I've got that shipping app backend pod creators role binding that's inherited. I've also got a local role binding for job creation, and I've got another inherited viewers role that's inherited kind of from the root of that directory structure. I can test that by trying to pull some secrets as Alice, which fails, as it should. If I try to retrieve some pods, that should be authorized, which it is, although I don't have any pods at the moment. So let's look at the quota definition. So this is the shipping backend quota, and as you can see in the hierarchy, it applies across all of the three subordinate namespaces there. So this is a quota that's managed by our resource controller that deals with the cross namespace quotas. It's got 3 pods, 1 CPU, 1 gigabyte of memory. And so I'm going to try to create a pod as Alice, and I'm going to ask for 80% of a core here, which goes through. And now if I go into and that was in shipping prod. So I'm going to go into one of the shipping dev, which is one of the sister namespaces. I'm going to ask for 30% of a core. And so 80% plus 30% is more than 100%. And this should fail that cross-cluster evaluation, which it does. And so because I tried to go above the limit of 1 CPU, for all 3 of those namespaces, it doesn't go through. If I decide instead to create a pod with only 10% of a core, meaning that the total quota used across those namespaces is 90%, that will go through. And so this is a way to allow for more granular tenancy without necessarily having to subdivide your quota further. So let's create something new here. I'm going to create a front end in addition to the back end, I'm going to set up a brand new namespace as though, say I was bringing a development team on board my clusters. So that'll create a directory for it. And then I'm going to create a definition for the namespace just to give it a name. And so you can see now I've got those files locally. And all I need to do to get that definition out of my clusters is make a commit to my repository and then push that up into the cloud. And there we go. We've got shipping app front end now active for 3 seconds, 5 seconds on both those clusters. If I want to look at the role bindings for shipping app front end, I can see I get that inherited viewers role, but I don't have much else there, so it wouldn't be of use to any of my developers. They don't have access to do much there. So what I'm going to do is create access for Alice, the developer there, by moving an existing role binding up the tree. So that pod creator role binding was at shipping app backend. If I move it to online, what it does now is apply to both shipping app backend and shipping app frontend. And so rather than kind of redefining that role binding, I can just move it, and the flattening mechanisms in policy management will deal with applying that to my new space. So let's push that change up. That's up in the cloud now. And so if I go and I look at the role bindings for shipping app front end, now I can see online pod creators is there. And I inherited that about 10 seconds ago. So that's the basics of GK policy management. One of the nice things about it is that it scales relatively well. The only bottleneck for it is the repository itself. And so if you're hosting that with a high level of connectivity, all you need to do is point your clusters to it, and they're all going down the same policy. One more thing I'll show here, if one of the nice things about source control is if you make a mistake, you can roll it back. If I revert all of those commits, I can push those back up to the cloud and undo everything I did. Wipe my clusters clean of any recent policy. And because these are resources that we're managing directly through the policy management, as soon as they're gone from the repository, I'll delete all the clusters there. So I'll stop there. That's kind of the demo. If anybody has any questions.
Is this tool open source, or is this a GKE only thing?
Right now, it's not open source. We haven't open sourced it yet. We've been talking about it, but we more or less got it built, and have been testing it with folks to make sure that it's useful. So open sourcing is something we're evaluating, but right now it's not released.
Cool. Thanks.
Yeah, I assume that there is some kind of a controller running in each of the clusters, which is basically watching the Git repo or wherever these policies are placed and pulling from there. So what kind of access does that, controller or tool, whatever it is, need? And it's like an add-on kind of a thing which can be installed on each of the cluster, something like that? Or
yeah, that's right. When we do an install in the cluster, all of our controllers, they run as pods. And there's a couple of them. One is what we call the importer. That's the system that's looking at the source of truth and pulling down that definition and writing a local version of those policies as CRDs. So every cluster has its kind of own version of that. And then we have another pod that's looking at those CRDs and writing against the API server to ensure that the policies locally in the cluster reflect the definitions that it's used. In terms of access, the importer has to look at the repository, needs to be able to connect to the repository. It also needs to be able to write the CRDs, and the system that's syncing to the cluster itself has a KSA, which is relatively highly privileged because it needs to be able to create and manage these resources. So the typical kind of setup is to install these things, provision the service account for the policy management piece, and then hand that over to the pod. And then once that's done, it can create all the resources it needs to do. In addition to those two things, we also ship, as I said, an admission controller, which handles the resource quota evaluation across namespaces. So when we need to look at policies that are specific to a namespace vis-a-vis resource quota, we use the inbuilt admission controller, but we have our own for cross namespace evaluation.
Got it. Cool. Yeah. Thanks.
Excuse me, in order to communicate with Git repository, do you use something like a kubeapplier or open source, or it's your proprietary implementation?
I don't know, Ray, do you know what we're using in terms of libraries to talk to Git? I think you're on mute there.
I said we use something called Git Sync, which was written by Tim Hawking. I don't actually know its open source status or not. So it's just what it does is read the uses SSH authentication. It uses Git cookies as well, and it can download. It just synchronizes to a local file system.
Okay, thank you.
It appears to be open source. It's on GitHub.
Sorry, I missed that.
It appears to be open source. It's on GitHub.
Okay, that makes sense.
Kubernetes Git Sync.
Yeah. So that's what we're doing. If you want to do, John, if you want to do a Kubernetes Get pods inside the Nomos system space, you can show everybody what is running in there. Right. So what you got there is the Git policy importer, and it contains both the Git sync code, and it also contains the code that John mentioned that reads from that repo and writes out CRDs or CRs that are defined by GK policy management that represent the objects that we are synchronizing. And we use the status of those objects to report on synchronization state, right? The policy admission controller is the hierarchical, the policy admission controller is a safety valve for us. So if bad stuff comes from the Git repo, we will not let things apply to the CRs that we create internally. And so think of it as like a validator to make sure that we're not getting garbage from the Git repo and letting it into the system. The resource quota admission controller is, as John described, that does the hierarchical evaluation of quota. The syncer piece is what reads those CRs and writes out to the Kubernetes API server. That's the thing that actually does the business of creating the namespaces and the RBAC of bindings and roles. So those are the four pieces. If you have any more questions, let me know.
Anything else we can answer for folks?
Have you guys seen a case to where the namespaces between two different clusters don't sync for some reason? Such as
meaning where it doesn't work, or where people don't want to have a namespace?
Well, let's look at the scenario where perhaps the one cluster is updated and the other cluster didn't. It didn't complete on the second cluster, for example. Have you guys seen that?
I don't think we've run into it in the wild. It is a case that we want to be aware of, right? There's a number of reasons why something might not work. For example, if there's a collision in names, it wouldn't apply on a particular cluster. And so one of the things we're working on and should release shortly is kind of status updates on all this. So right now, if there's an error, we do publish logs and it is something that you can kind of dig in and understand what happened. But we are planning on kind of adding status information to all of our CRDs and making it much easier to see the last successful sync state for all of them, and giving people the information to deal with cases like that. Although I will say, in practice, it seems to be a fairly rare thing, but we do recognize we need to kind of handle it as an edge case.
And there's going to be, the idea here is you'll know the state of every cluster. And we expect that, especially in distributed environments where clusters may be behind poor connectivity, right? You could see some amount of latency difference between applications, and you also could see breakages. But this is the system is always trying to pull the repo, so it is self-correcting, right? So if something doesn't apply, it's either because there's a conflict, which is something that we would note, or there's a bug, right?
Excellent. All right, thanks.
Ray, can you say a bit more about clusters that may not be homogeneous necessarily in size? Say customer has a small cluster A and a larger cluster B. It seems like having a global policy, whether it's related to quota, may not apply uniformly.
Yeah. So what you're looking at here is our alpha version. So what I don't know if you could hear Christian, but the idea here is that this is meant to work in heterogeneous environments. So you could imagine having in a given region where you don't need that much connectivity, you might only have a small cluster versus in your main region, you might have a large cluster. And you may only want to give certain teams access to that small cluster because they have critical workloads that have to run there. And so the way that we think about that is that the namespaces will exist, right, on all of those clusters, but the quota would be minimized for the thing. So you might have 0 quota on that small cluster if you're not one of the teams who needs to run there. And so that feature is what we call per cluster addressability, right? And the idea there is to allow people to take resource quota and say, okay, I want to apply it to my large cluster, and then I want to apply this different quota to a small cluster for the same namespace. And then that allows you to deal with the heterogeneous nature, and across all policies, that feature would work. Yeah.
Yeah.
And a lot of the lessons that we've used to inform some of this product come from our experiences here at Google. And so we've tried to incorporate some of those. And the one that Christian just brought up is one that's very common here.
Are there any other questions we can answer for folks?
Yeah, I had a question. Is there support for specifying locale policy, such as per region policies, or the ability to designate where workloads should or should not run from a geographical standpoint?
So I think you could accomplish that with the mechanism that Ray just mentioned. If you're set up in such a way that you've got a cluster in one region, a cluster in the other. Is that the kind of use case?
Or what about, I think what we're talking about is maybe you have per cluster addressability, but you have the ability to apply labels on top of these clusters. And you would define labels to be a region, for example, and filter that way.
Yeah, so that is something we can do with that mechanism, right? And so that's how the mechanism works, is it uses labels to say these clusters are part of this environment, these other clusters are part of this other environment, and then you apply the policy to that label, to the selector. Is there anything else I can answer for folks?
One last question for me. Can someone explain how the quota controller works between two clusters? You did an example showing, hey, if I have a cap limit on 1 gig or 4 gigs of memory, and I tried to overcommit it, that you guys were able to perhaps say, hey, you are over your limit across multiple clusters. Can you explain how that works, the mechanisms for that?
It was actually within one cluster.
Oh, it was? Okay.
Yeah. So you can basically share quota across a set of namespaces within one cluster.
Ah, okay. Gotcha.
Cool. Well, thank you.
Thanks, guys. Thanks, guys, for doing this.
Yeah, thanks a lot, guys. I just wanted to mention, if there's any interest in taking a look at this or playing around with it, feel free to get in touch with me. We're testing it, alpha testing it with folks right now. My email address is my name, John Murray, at google.com. Happy to discuss it further with folks if there's interest.
Thanks, guys. That looks really good. Thanks a lot.
Thank you.
Yes. Thank you.
Okay. There is no other item preset on the agenda. Is there anything else anybody else might want to talk about?
One thing I'll just mention is in our last meeting, I took an action item to make a change to the cluster registry to add something that marries a cluster registry record with a kube config so that you can express in the cluster registry what credentials to use to contact the cluster. I have not had a chance to do that yet, but it is on my list of things to do by the end of this week. Sorry for the delay.
Okay, cool. I'll take a look at that because I read the notes and I couldn't quite make out the proposal just in the terse notes. So I'll send you feedback based on what you sent out this week.
All right.
Okay. Thanks, guys. So we can probably close the meeting now. I'll see you again in 2 weeks.
All right. Thanks, Irfan.
Thanks. Bye.